Hello, my dear students. Welcome you all to Sri Jaindra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, we have started the chapter Biomolecules, carbohydrates. We discuss about the monosaccharides and disaccharides. Today, I am going to start with polysaccharides. So, starting with polysaccharides, I would like to start with a very important definition. As we have discussed the relative configurations, the cyclic structure of glucose in the previous class, now it's turn for epimers. Okay, epimers basically there are many sugars which are closely related and they differ only by the stereochemistry at a single carbon atom. For example, glucose and mannose, they differ only at one position, the second stereo carbon, which is the first asymmetric carbon atom. First asymmetric carbon atom, right? Sugars that differs only by the stereochemistry at a single carbon are called epimers. They are known as what? Epimers. Known as what? Epimers. Okay. And the carbon atom through which these epimers exist, okay, if the number of carbon atom is not actually specified, it is assumed to be the second carbon. Therefore, glucose and mannose are C2 epimers. Glucose and mannose are C2 epimers. Okay. Glucose and galactose are C4 epimers. Okay. The C4 epimer of glucose is galactose. Okay. For example, if I'll show you with the help of diagram. This is D-mannose. This is the second carbon. Okay. This is D-glucose. So here you can see the second carbon. These two are epimers of each other. Okay. So these are two epimers of each other. Now we are going to discuss about polysaccharides. Okay. Polysaccharides, they are monomers of, they are polymers of, sorry, they are polymers of monosaccharides. It is a natural polymer of monosaccharide. Okay. The polysaccharides, they may have 100 to 3000 monosaccharide units. Okay. Among the natural polysaccharides, cellulose, starch, and glycogen. Natural polysaccharides like cellulose, starch, and glycogen are derived from same monomer. That is glucose. Okay. So we are going to discuss about starch. It is a polymer of glucose with the molecular formula where the value of N lies between 200 to 1000. It is the chief food reserve material or storage polysaccharide of plants, and it is mainly found in seeds, roots, and tubers, etc. etc. Okay. Wheat, rice, potato, they all are rich source of starch. It is a mixture of two components. A water soluble amylose, around 20%, and water insoluble amylopectin, 80%. Okay. Both amylose and amylopectin, they are polymers of alpha D glucose. Okay. Amylose is the linear polymer of alpha D glucose and contains about 200 glucose units. Glucose units which are linked to one another which are linked to one another by C1 of one glucose to C4 of another glucose. Means the glycosidic linkage is between C1 and C4. The next is amylopectin. It is highly branched polymer. Okay, and it mainly consists of several branches of short chains. Mainly consist of several branches of short chain around 20 to 25 glucose units which are joined together through C1 of one glucose and C4 of other. Okay, the terminal glucose unit, that is C1 of the terminal glucose unit in each chain, terminal glucose unit, means the C1 of terminal glucose unit in each chain is linked to C6 to make a branching of other glucose unit. So in case of amylopectin, there are two glycosidic linkages. One is between C1 and C4 and the another one is C1 and C6. Okay. Okay. Starch on hydrolysis. With dilute acids gives dextrins which further hydrolyze to form maltose which further hydrolyze to form glucose. Okay. Starch is a non-reducing sugar as it is unable to reduce tolerance reagent in Pelling solution. Okay, it is used as food, okay, and food reserve material. Okay, it is used in coating and sizing of paper to improve writing qualities. Starch is used in textile industry, textile fibers. Okay, used to make dextrins, glucose, and ethyl alcohol. Okay, starch nitrate is used as an explosive. Then comes cellulose. Okay, it is a chief component of wood and plain fibers. Okay, like cotton. It is insoluble in water and is tasteless, not having any taste. Okay, because it is not soluble in saliva. It is non-reducing carbohydrate and it is having high molecular weight. Okay, the formula of cellulose is where it gets completely hydrolyzed by acid gets completely hydrolyzed by acids, giving D plus glucose as the monosaccharide. Like starch, cellulose is made up of chains of D glucose units with a glycosidic linkage between C1 and C4. Okay. When treated with acetic anhydride, and sulfuric acid, that is H2SO4 and CH3CO, acetic anhydride, okay, it forms octa-O acetyl cellobiose. Okay, all these glycosidic linkages are beta C1 to beta C4 linkages. Okay, high molecular weight, and around 1500 glucose units per molecule of starch. Per next, the terminal groups, they can be analyzed by methylation with alpha methyl sulfate, okay, or per iodic acid oxidation gives a chain length of 1000 glucose units or more. So methylation and per iodic acid solution gives a chain length of 1000 glucose units per molecule. Okay, these chains are held together by a hydrogen bonding, help to join the remaining units. So basically hydrogen bonding helps to join these long chains side by side, okay, in the form of rows, okay. The rope-like structure which themselves are grouped to form fibers we can see in the molecule of cellulose, okay. Now the properties. The glycosidic linkage can be broken by acid. So the glycosidic linkage, it can be broken by acid, okay. The acid degradation of the glycosidic linkages of cellulose yield many molecules of D-glucose, okay. Each glucose unit in cellulose is having three free hydroxyl groups, and these are at the positions at which reaction occurs. Three free hydroxyl groups are the site for reactions. Okay. Cellulose, because of free hydroxyl group, forms esters. When treated with nitric acid, and sulfuric acid, it converts into cellulose nitrate, gun cotton, which helps to make smoke-free powder is very nearly completed nitrated cellulose. Nitrated cellulose or cellulose trinitrate. Okay. Pyroxylene. In case of pyroxylene, it is having less highly nitrated material. Less nitrated material. Having 2 or 3 nitrate groups per glucose unit. It is used in the manufacturing for making plastics. Okay, like celluloid or colloidal. Okay, which are used in photographic films and in lacquers. Okay, it is inflammable and forms highly toxic nitrogen oxides upon burning. Okay, cellulose on alkylation forms ethers. They form ethers. Understood? So this is about cellulose and starch. I hope you got it. Okay, epimers we have discussed. Rest we have discussed everything. Okay. Now, as we have cellulose, glycogen is known as what? Animal reserve or animal starch. Glycogen is also known as what? Animal starch or animal reserve. Okay. All these reserve food materials, they help very much during the condition of prolonged starvation, okay, or the stressful conditions. So this is about cellulose, starch, which are the polysaccharides. Okay. I hope if you are having any problem, you can ask me. So my dear students, we have covered the carbohydrates. Or when we can say, we have covered the carbohydrate part of biomolecules. We will be meeting in the next turn. Okay, discussing the other concepts of the chapter. Till then, bye bye. Take care. Stay safe. Stay healthy.